Broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to Unpacking the DER Tech Stack. Our webinar today is with Jelly in partnership with Infocast Events. Today I have with me Ryan Wartina, founder and president of Jelly. Before we get started with our webinar today, if you have any questions, please type your questions in the Q&A box in the lower right-hand corner of your screen, and we'll make sure to answer your questions if the time permits. Thank you, and now I'd like to welcome Ryan Wartina.
Catherine, thank you so much for inviting myself and Jelly onto this webinar. I believe this is going to be part of a Internet of Energy series around just the new grid that we're starting to all embrace. And I believe a lot of us are here today because we know that distributed energy resources can be very valuable to the grid and to the market. We're also seeing a lot of networked assets that are really pushing that to really become a reality. Seeing that there's a lot of valuable assets that could be used that's behind the meter or on public internets, and how do they get over to be useful for the grid and for the market. And so that's going to be really the main look today, is like, what is the software that's currently being used to design and operate the grid, and what's the software that is emerging on that distributed energy resources side. And well, a lot of this question really started to come to because a lot of conversations being had around what is aggregation. So that's another goal of this discussion and presentation today, is to really unpack the DER tech landscape by first going through a historical look at what software and what techniques were used to build and operate the grid. And then go into what is aggregation and different ways that aggregation is going to play out in a distributed energy world. So the picture here is really, we have a number of industries coming together, or really all looking to do the same thing: sell energy services from networked assets. In this scenario, I'm neither saying it's behind the meter or in front of the meter. It might be utilities that are participating. It might be solar developers, which are going in to develop not just solar, but energy storage and EV charging, and or it might be the EV manufacturers themselves. Each one of them are going to have somewhere between a 20 to 100 kilowatt generator just waiting to be able to provide services. And ultimately, the networking companies. When we start seeing, the Intel, IBM, Googles of the world entering in to go ahead and help solve some of the networking issues around integration, aggregation, and just general network management of a Internet of Energy. It's going to be a great time. I have a lot of information today, so we're going to start off with something a little bit fun. Next slide, please. If you remember the old cartoon of the Transformers, the story of the Transformers is not just that they transformed their shape, but they actually scoured the universe and the universes for chemical things that they could pull into energy, or energon cubes. And they went ahead and built these energon cubes. They were able to manifest them from their own bodies and fill them and trade them and exchange them. And really, we're kind of getting to an interesting point here once we start bringing a high level of compute and data visualization and just an understanding of the grid. And so I like these pictures because it's like it starts to give energy a very visible feel. And that's been a big goal for myself, is just to really understand how the utility grid works, how its business models work, but also like how it was designed and how it's operated, and all those pieces that go from transmission all the way to behind the meter. So again, that's another goal here, so to kind of start unpacking that whole landscape. And so ultimately, next slide, please. We'd love to get to a world where maybe everyone is a little nano ISO, or everyone can be their own network generator or utility participant in getting the peer-to-peer energy. We're not quite there yet. A nice goal to have, but there's a long ways to go. Next slide, please. And so to really kind of set the framework of our discussion today, we have a number of players in this landscape of our traditional power generation. We have our transmission system operators that are going ahead and brokering between big generators and to go ahead and bring them into different utility grids. And so we have our transmission system operators that are then making capacity available to distribution system operators. That's our traditional utility grid. And then all of a sudden we have in here a little notice of an aggregator or a retailer. You know, in a deregulated utility, not just the generation side is deregulated, but also the retail commercial side is deregulated. And so you have a very frothy activity of different retailers in a healthy deregulated environment. But also we may have a lot of distributed generation resources and distributed energy resources distributed around the network grid at different levels. And you know, as we've been going through and you know, working on software ourselves to network energy storage and deploy it at different points in the electrical grid and actually make it useful for different entities, we kind of come across that there's some missing holes in what's available right now to actually make distributed energy resources useful for the electrical grid. And next slide, and we're going to start to kind of point out what those are. So just to really start, we're going to work our way across this slide from the left to the right. And these are not meant to be a comprehensive list of companies that are providing software solutions in the space, but more just an example of some of the software that's out there, and this is what's been historically used. And also, we're kind of starting from the top because I think it's important to understand all the software that was used to design the current grid, understand how the current electrical grid is operated, and the level of complexity that is there. Of course, for people who are in the software space and the computer sciences and the information sciences, this level of complexity is a welcomed one. But also just knowing what the pathway is to get there, to get to understand there, is important also. So we'll start here with the very first. So entities who are building generators or own generators, or are starting to work into selling into transmission grids or selling to utilities, will often utilize what they would use plexos for power flow commitment and unit dispatch. And again, this is now not just for their generators, but also for flow within the transmission grid. And common software here would be Plexos, but also ProMod by ABB. And most recently, I believe that the GE Energy Consulting division released their GE Maps, so more of a market simulator, LMP, locational marginal pricing simulator. Now, a lot of commodity trading houses also use this type of software to understand capacity that's available in transmission lines. A lot of generators are owned and sold and bought, and that's really the high-level energy market that's going on there. And one vision would be that ultimately the distributed energy resources could also play in that type of market. And but we'll show some reasons why we have some gaps to fill there. As we move from the production cost tools, we move into transmission planning. One of the most prominent there is Siemens PSSE software for transmission planning. Well, then we start dropping into distribution planning. And we're looking at distribution planning from looking at GridLab-D, and companies like Synergy have different modules that will pull in models built on GridLab-D. But it's really interesting to take a look at a historical evolution of any utilities grid, and that grid model is constantly evolving, constantly forming. It's even being updated dynamically in the field often. And so having a really good grid model is very difficult. Now, traditionally, distribution utilities will run their grid models for a 72-hour forecast. But there's a difference that happens there when that distribution planning or that distribution load forecasting. I'm going to move another step over from not just planning now, but now into our general distribution automations. And This actually has a lot of different names, everywhere from just an energy management system to a distribution management system to the distribution energy management system and all the combinations thereof. But the point around getting into the distribution load forecasting and marrying that with the models these are constantly changing. You're conducting 3-day power flow models, but really what's happening is the output from those power flow models on the branches and the circuits are now informing set points. They're informing set points for safe operation for that time duration. So they're not actually doing the same type of power flow and dispatch with unit commitments. Remember, our units are energon cubes of sorts. That's being done at the production transmission level for trading in the distribution system. So there's a kind of a fundamental a piece there that if we want to go ahead and have distributed energy resources participate in markets, much as the transmission level, then we're probably going to need to be able to have those DER assets, be able to schedule in, be able to make unit commitments. But we're now operating in a distribution automation framework, which is really just setting set points. So you start to see the gap. But a lot of companies are starting to kind of step on in to go ahead and bridge that. And we'll start kind of opening that up here in a moment. We do have traditional distribution automation. These are the things like the cat banks that you can go ahead and change different set points per the power flow modeling. Then we get a little more dynamic, right? So we get companies like Gridco Systems coming in and putting in variable buck boost converters around distribution networks for more active management of these systems. Then there's a whole going ahead and being able to build a whole software for advanced distribution management system is something that's only a few companies are really kind of suited for at the utility scale, in my opinion. And those are companies like General Electric and Siemens and Alstom. Companies that have long helped actually invent the grid and understand the depth. There's a lot of ways that they can plug in. We're really happy to see the different collaborations between IBM and Intel and different networking companies, along with GE's and Siemens's focus on developing very great software for API and interaction. Being able to have platforms that we can plug in and have different modules for different services is going to be critical to the future. I think both companies are doing a great job on that. And then we're going to move over to the historians, where all the data is stored. OSIsoft had market dominance for a long time with their Pi server and Pi points and Pi tags. Oracle has come in to go ahead and try to take some of that market, and that's been an interesting evolution to watch. At the same time, there's been non-relational databases like NoSQL, it's called, that is really good to hold a lot of different types of data, such as MongoDB. These type of databases are often used in web environments where you have a bunch of distributed locations and you want to be able to bring databases together and back and forth. And a lot of utilities are starting to look at the idea of using some of these kind of open source and very well tested and highly scalable relational or non-relational databases. And finally, I just want to say that about metering. Metering is actually going to be one of the holes I kind of want to draw some attention to and just bring some thought process around that. We know Itron, Silver Spring, Landis+Gyr. Landis+Gyr was bought by Toshiba. Landis+Gyr is one of the first companies there to actually have meters that have provisionable space. And I know the rest are working on it, but they have provisionable space for some intelligence right at the meter, right in between the utility and maybe the retailer and the customer. Is actually a very interesting location for some local compute. So we see good things there. But all of this, I want to go ahead and say, we're going to show some holes, but first, next slide, please. The design goes much farther than what we just talked at a high level here. There's a lot of, deeper level harmonic analyses that go on. The thermal management of the grid is a very important task. And just like doing the simulations has been an area of a lot of effort for utilities. Really, it's the distribution management system and the outage management system for utility that they spend a majority of their operational account on software on. So being able to advance distribution management system and be able to advance outage management systems and possibly integrating aspects of all of these together is probably the future for utilities. But next slide, please. So now I want to introduce a number of the new companies, the new entrants, the companies which are kind of bridging the gap. So you'll notice kind of architected the slide in columns, and really it's thought of that a lot of these areas are silos. The traditional planning in a utility right now happens in what's in California was called a long-term procurement project. So it's really over a 10-year scope that utilities are planning on what's going to be the load growth and the population needs. And so but that planning process is actually rarely integrated in a software or mechanical way into the operation system. And also, the metering data right now, metering data has really been strictly used as billing and then warehoused. The intelligence that can come from that meter data, hasn't really been utilized. And there's a number of reasons for that. Utilities are just now kind of getting their energy management system or their distribution operations into a place where they can use that data to go ahead and hire people that can be trained to go ahead and take advantage of the value that can be brought from using advanced automation. Now, not that I don't want to say I don't want any lashback to say that utilities aren't using this. I mean, it's right now. It's been a very sorry. There we go. Utilities have been advancing, but now a lot of software companies are entering the realm with some very interesting solutions that actually bridge. And so one of these bridges, there's an organization called Better Grids. There's actually a number of efforts sponsored by ARPA-E around grid models and trying to track grid models, make depositories of grid models, get interoperabilities between different grid models, and have really grid model collections out there. So having those grid models are really critical if you wanted to say, where is the proper place to deploy a distributed energy resources? That would actually need to work all the way back from the meters all the way into distribution load forecasting, into distribution planning. So it's really important to kind of have those at hand. Now, normally this is the utility's job to go ahead and do their modeling, but looking at locations of where there are capital projects planned is actually a really good way to kind of see where's the potential places for non-wires alternatives or other DER deployment strategies. I do have on here, as we were kind of working across from left to right, demand response aggregators. Demand response aggregators such as Enernoc and Converge have been very active to participate in demand response programs for utilities and for markets. But really, when the utilities call on these are almost for system-wide or time-targeted, as in New York, deployments. This is not necessarily for local circuit, local feeder balancing or deferral for a specific transformer, right? These are more network-wide. So much data is going on that there needs to be situational awareness, and companies like Spacetime Insight have really been pulling together a number of the different data streams to go ahead and do this situational awareness and with visual analytics space. Then we want to kind of talk about what's missing. What we've really noticed to go ahead and make distributed energy resources viable or valuable. make distributed energy resources valuable to the grid, not necessarily valuable to the market, because you can go ahead and aggregate a lot of DERs for market operations, but to make it valuable for the grid, you really want to know what is the state of the low voltage and the medium voltage distribution system. Now, most distribution systems are measured and metered all the way down to the substation. So all the way down to the substation. But very few utilities have their low voltage or their medium voltage and their low voltage systems SCADA'd, or bringing back telemetry. If those levels of systems aren't being measured, how does the utility know really what is the load on a local transformer? The transformer outside of your house will feed about 1 to 10 homes. How do you know what is on that loading? Well, there's companies like Offsense that have developed low and specifically low voltage SCADA systems. Sentient has medium voltage SCADA systems. And then we have companies like DVI. DVI goes ahead and leverages a high density of meter rollout, and actually can do it statistically to go ahead and start backing out what is the state of the low voltage and medium voltage system. Now, both of these approaches one is a finer level of resolution of metering. Now, utilities have yet to really be able to justify or have the proper reasoning to go ahead and rate base a lot of low voltage and medium voltage meters. It was obvious on what the rate base case was on why to put smart meters in people's homes, for ease of billing and things like that. But the low voltage and medium voltage SCADing hasn't had the strong support to have mass rollouts. So, we can see now for DERs to actually be integrated into the system, we need to know what's going on the lower sides of the system. So that's been one of our learnings here at Jelly, is like that there needs to be other approaches if a utility doesn't have locational awareness of what's happening on the low voltage and medium voltage system, and maybe only at the substation. Either they need to have enough smart meters deployed to where it can do data analytics in real time, a la DVI, or do deployments of specific low voltage or medium voltage SCADA points on the distribution system. And so these are really key critical pieces for any utility who's looking at doing a pilot of DERs that the intent is for it to be useful for the local grid. And kind of thinking, okay, need to go ahead and have the local metering, and then also need to have a place for that information to come to, which we come to the bottom of this page. And it talks about the integrated DER planning and the distribution energy resource management systems. So the big DERM systems are starting to be dominated by companies such as, well, what used to be Alstom, Ventax, IBM and Schneider both have variants of theirs. And these are new systems. This is like functionality beyond the normal network or the distribution operator or network operator. This is what we would call a distribution system operator. There's more kind of the system information, the system technologies coming in here. Now, what new entrants such as Prosumer Grid, Opus One, Smarter Grid Solutions, these are all software companies that are building software kind of like arm in arm next to Ventex and Alstom, but basically working to build software that utilities would use and integrate as a new systems, a dynamic systems layer within their distribution system. And it wouldn't just be about automating demand DERs, but it would also be integrating the planning, because really it's about where do you locate DERs. So you need to have the low voltage, medium voltage data coming into planning almost in real time, not in a 10-year long-term procurement process. You need that also, but also in a real-time loop where that low voltage, medium voltage, AMI data is coming into an integrated DER planning system. And then that output is going into operations and and the dispatch sequences and for power from unit constraints on the distribution system. So, sorry, talking a lot around there. I know we're actually kind of coming up on some time here, so I'm going to ask Catherine, go ahead and pass by this next slide. And we're going to, so this is just a slide, this is a slide of kind of showing where we are in the DER space. Really anything kind of behind that 69 kV is in the distribution system. So these are kind of the medium voltage and the 34 and 4 kV, and then the low, well, that's the low voltage, and then the house voltage. Okay, next slide. This is actually an important slide because now the question is, a lot of that first part of the history of the software that built and operates the grid, a lot of that operates on private intranet. Utilities run mission critical systems, very large systems. These are all on private networks. Very rarely, if ever, most likely never, do public intranets interact. Really, all interfaces are NERC, SIP, securitized. Now we enter into the situation where we have the classic method of design and operations. Now we're entering into having distribution systems operations coming in and leveraging a lot of assets which are on the public intranet. So now it's a question for the utility. How do you go ahead and make sure that you minimize your security surface? Well, you can see right here, if you go ahead and have a secure managed service and something on the public internet that can go ahead and take a lot of the inputs from these distributed energy resources safely and exchange just the required information over to the distribution systems operation. Again, another step of the integrated operations. That would be the best way. Not the best way would probably to have millions and millions of DERs interface into a utility DERMS system. We don't know necessarily the whole level of threat from here, but we would guess that there is some. Now, moving from here, really kind of drawing a line between like what exists on the private utility intranet and what exists on the public internet becomes rather important. Next slide, please. And so we can almost draw a line. The boxes on top are going to exist on the private intranet. The pieces below, all this new work, all the new work that software companies of our age right now are going to be building, exists below this line. This is software which exists on the public intranet. We have to do actually all the same things that was happening up in the distribution and the transmission grid, and really more like the transmission grid. Everywhere from aggregation services to scheduling and dispatch, program registration. If you go ahead and you have your EV or your energy sources and you want to be part of other programs. We've been working on some micro market energy exchanges, kind of an interesting idea of get automated machine-to-machine energy transactions going. We focus on system controls and optimization, but there's lots of space in the analytics and reporting, and we're seeing new retailers starting to leverage a lot of software to provide retail energy services from networked assets. And of course, system design and modeling is not just for the transmission and the distribution system, and all the way to energy asset financing and integrating in EVs. So we're in a very interesting time to have a lot of new space open up, but to really make those DERs useful, there's some pieces on the distribution network that we need. And I do want to highlight, next slide, please. we are Jelly's part of a RPE nodes program, and nodes stands for Network Optimized Distributed Energy Systems. And the questions ourselves and 12 different groups ranging from GE, we're working with DNVGL, the National Rural Electric Cooperative, in there, PNNL, UCSD, are all working to figure out how can we quickly, dynamically aggregate distributed energy resources, keep public and private information separate, and can we do that really fast? What's the bandwidth required? What's the latency? Can we get it automated? Can we get it traceable? Can we have it all going with smart contracts? So some very interesting work that the Department of Energy is backing on this, and really starting to answer some of these questions about how do we bring the market in. And we are actually starting to get to time limit here, so I'm going to ask Catherine if she could bypass the next couple of slides. I'll actually pause on the picture here. I'll be looking forward to sharing more results from our RPE nodes project. What we're doing is we're aggregating 100 distributed assets, and for doing this thing at home, but then also for growing food and making water clean in Texas. Okay, and actually we're going to go ahead and pass by this one also. This is more of another layer, but really want to get to wrap up here with about a discussion of what is aggregation. And by doing that, next slide, please. Really, it's talking about the different participants and types of aggregation. And next slide, please. And then we feel that to really access value, behind the meter, you'll need to have some type of aggregation. Now, not necessarily true if you're operating a 100 megawatt generator. You can go ahead and probably have a single point of operation there. But as we're moving in, as companies are looking at developing sites and having fleets and having dynamic assets, aggregation becomes a very important capability. So it's just a really important base capability to have. Now, it's used a lot of different ways and for different participants. And I'd like to kind of go through kind of the stack here that kind of putting forward. And any company could have a number of these, all of these. But one thing we know is, like, as the internet gets into things, it really kind of starts making horizontal layered services of things. And so I really like to think of these as layered services ultimately one day. So at the very bottom of aggregation, we have an informational aggregator. And that informational aggregator might just be getting metering data. They might just have weather information. It might just be forecast. It might be who knows what, but it's not necessarily controls. It's not ownership. It's aggregated information. Then we move up a layer. The technical aggregator. This is someone who would be authorized to read specific devices or assets, one that might also be authorized to actually control them. So under that control part, that's where we say this is a technical aggregator, be able to turn it on and off, tune in its power. That is a level of controls that's is necessary and difficult and beyond just monitoring. Then we move up a layer and say, who's the financial aggregator? Who's the one that has the contractual, obligations to the client? Who's the one that's responsible there? And so that might not be the one that's the technical aggregator, might not be the one that's the informational aggregator. Then even that financial aggregator, they might not be bonded to participate in the market. It's a good shiny penny to go ahead and get into the market to be a market participant. So some people use other aggregators to go ahead and be their market entry as scheduling coordinators, etc. Now we move to the other side, and there's a utility shield. I have a feeling there's going to be entities that pop up that really kind of offer the utility shield, kind of like the really rigid framework that DERs can be safely aggregated into. This might actually be the place where solid markets really form, so this is going to be a very interesting spot of evolution. And then as we step up and we kind of cross the air gap, there. You get into the utility system operations on private networks, and above that is the classic utility distribution operations. So that difference between just distribution and distribution systems again. Next slide, please. And now we want to think about, like, we have a framework now of aggregation, and we have that framework is kind of leading us up either one or two sides of these columns. You know, I was actually recently told the story that one of Enernox's main business units was aggregating aggregators. And I thought that was actually really interesting, because that talks to the fact of, like, stacking aggregation and, you know, working to go ahead and make the cost of aggregation low cost, right? The cost of aggregation, the cost of transactions. Lowering the cost of transactions is really kind of what, you know, greases the skid, is what greases the skid on a larger scale for solar and distributed residential solar financing. So again, all working with technologies now, from smart contracts to go ahead and try to lower that. And I have these little symbols here of two arrows crossing, and that's a symbol of an energy exchange, or what we call a micro market. And either place is a place where there could be a market set. Now, there'll probably be steps into this before there's a market set. There'll just be someone going ahead and asking for specific service through programs. And also, I kind of like to think about the idea that if you're going ahead and selling value, if you're aggregating value for the utility or the network, you're actually operating within the DERMS side. But if you're now getting to the market and you're aggregating power to go ahead and participate in the different power products, you're effectively making a virtual power plant. And the line obviously blurs. I'm sure there's going to be a lot of discussion about, you know, what's the difference between DERMS and virtual power plants, just as what was the definition of a microgrid. But that's kind of really where I want to wrap up right now. I have a number of other slides that, of course, I would have loved to kind of share with you. But I think we're at a really good stopping point here. I kind of achieved what I wanted to do, was kind of like share with you my perspective on the different software that's been used historically, the differences between the transmission grid and the distribution grid, and what we need to kind of see slide in to really see DERs useful. I think we discussed the different holes that, you know, are currently possibly in existence that would block or that would prevent a DER pilot to go forward. I will mention that you know, we're working on what we call a granular DER transactive pilot, and that's using SEP2 commands. We're feeling that SEP2 will be that main communication channel, and in a way where you can go ahead and, you know, target deploy metering on transformers. So I will stop there and see if there's any questions.
All right. Make sure to put your questions in the Q&A box, and let me take a look right now, Ryan. Let me see. Currently, we do not have any questions. So if anyone had anything they'd like to ask during Ryan's presentation, please do right now. We'll give you guys a moment. Alrighty. Well, it doesn't seem like we have questions, but I will go back to your previous slide. If you have any questions in the future, please make sure to email Ryan at his email address here. Actually, sorry, we just got a couple questions. Excellent. Thank you guys so much. All right, so Nick asked, what kind of assets are used in pardon me, is it ARPA-E nodes?
Yep, RPE nodes.
Okay.
Yeah, the RPE nodes project is actually using a variety of generators and loads. There are let's see, there's residential solar and storage systems. There's storage, energy storage, residential storage only systems. There's even a natural gas generator there. At the site at Group Nair is actually up to 90% renewable energy sometimes, because it's a kind of a contract test site for wind and renewables too. So there's a 1 megawatt solar generator there. We have a number of EV chargers. There's a number of other loads. So the loads are actually all going to growing artisanal lettuces for local restaurants. And so there's loads on lighting, on water pumping, and on temperature control of the facility. And yeah, so the goal there is watching 100 distributed assets. So I think we're up to about 27 assets now at that Group Nair site.
Okay, thank you so much for your answer, Ryan. We have a question here from Samuel, and he asks, what capabilities do you think CCA should be deploying?
Yeah, I think CCAs really could, take a look at what the retail environment is happening in, Australia, New Zealand, and the UK. CCAs are kind of structured in a similar way where they can, not only, buy from their own sources that they're deploying, but also work with the market and give those type of rate structures to their clients. What I find interesting is that, CCAs, could have a very good opportunity of having very strong, marketing campaigns. And, it's been watching the retailers in Australia and New Zealand, they're been very sexy, to say the least. So I think, a lot of these technologies, DERs for sure, to go ahead and start getting, higher penetrations of, targeted renewables. And really running operations of, combined, large assets of community solar for both commercial and residential, deploying, campus microgrids and running residential and commercial programs. I think one thing we didn't cover was the Jelly technology set, where we provide design software, automation software, and management software. So that allows us to go ahead and rapidly design systems right-sized for lots of buildings. We've processed, thousands of buildings at this point, and, happy to work with any CCA who wants to go ahead and, right-size systems for, thousands of buildings.
Thank you for your answer, Ryan. We have a question that just came in from David, and he asks, any special consideration for aggregating EVs?
Oh, absolutely. I left that as a whole section there. I think, EVs are going to play a very important role now when, as the car companies roll out that capability. I mean, those are some very powerful generators with storage that have already been rationalized on their investment. So, and they should be able to be a nice dynamic asset. Now, kind of thinking through where cars are during the day and how often people drive them, and, really more probably starting thinking of cars as revenue generating assets, like people who drive Lyft or Uber do today, is going to probably be more of the mindset. But, we're starting to get good penetrations of EV charging. We need a lot more EV charging, and that's going to have a big effect on the grid too. So all of that needs to be worked in. Public-private partnerships are going to be really important.
All right. Well, thank you so much. That'll be all our questions for today. Thank you for asking. And thank you, Ryan, for answering. I'm going to go to the last slide. I just want to say thank you again to Ryan for this excellent presentation, and everyone in the audience who tuned in. I just want to remind you that you will receive an email with the recording of this webinar within 24 hours. You can replay it as many times as you'd like. And if you're interested in InfoCast, if you'd like to check out our events, please visit infocasinc.com. infocasinc.com. That's infocasinc.com. And of course, please check out Jelly as well. Thank you guys again, and hope you guys have a great day.
Thank you. Thank you all for attending. Feel free to contact me.